simplify some code in this problem. We need to, if n is given, then we need to return nth Tribonacci number. So Tribonacci's number transition function's definition is given to us, and this is a dynamic programming type of question. And in dynamic programming, the main goal is to, in any type of problems, the main goal is to come up with a transition function. So since it is given to us, this is a straightforward problem. We could just jump into implementation right away. So first thing first, we can create a DP array with numbers of this, assigning also allocating some time for given n, because in the end we'll be returning DP's n value, and then again is DP, it will hold the answer. So since it is given all those base cases, let's write. So basically we are just taking this formula and transferring into coding. So dp 0 for a base case, it's 0. So if n is 0, then Tribonacci number, the result will be 0. So if n is 1, then Tribonacci will be 1, as it says right here. And if given number is 2 right here, so Tribonacci number of the result will be in 1. And this is our transition function definition. So since we defined up until 2, the starting point could be from, we can start from 3, and it will go until n inclusive. And from here we will just have our DPI, and with this formula, with this transition function. So in the end, our DPI will be holding this result. So let's define this. So since this is for, we are trying to get DPI for this is n, and then we could subtract -3 out of all of from here. So I subtracting 3, because this is n right here. If we subtract -3, then it becomes this way. So addition, and n plus 1 -3 will become n negative n minus 2. Yeah. So I minus 2. Here for readability, and dp I, and then in here 3 subtraction. If we subtract 3 from 2, then it is 1. So when it is 3 initially, 3 -3, it's 0. We have already defined for that. 3 negative minus 2, that is 1. We have defined for that. And 3 minus 1, 2, we have already defined for that. And some base cases. So in case when n is 0, then we can see that for that we're just returning 0. And in case when n is 1, we can see that we're returning 1. So not to have out of bounds. And when it's 2, then 2 plus 1, we have a size of 3. So 0, 1, 2, we have this will become size of 3. So it's not going to be out of bound. Array will not, the index will not be out of bound of this array. So let's run our code. Let's submit it. So in this, the runtime is O of n, where n is all total elements in given in this number, and space complexity is also O of n, where we needed an extra space to hold all those values in our DP. However, if we want to optimize our space complexity, we could actually drop it to O of 1, the constant time, so we can actually do that. So instead of creating an array and allocating some memory, we could just create some variables and then assign it to it. So let's assign it. So we'll just assign to these variables, and let's get rid of this. And then instead of this formula, we can actually say that current, and then all this will be replaced by our variables, and we'll just reassign our kind of like update our variables now. So prev1 will be getting reassigned to prev2, and previous 2 will be getting reassigned to previous 3, and previous 3 will be getting reassigned to current. So in the end, previous 3 will hold our answer. So let's run it and submit it. So in this case, we optimized our code and we dropped the space complexity to constant.